Alright, so we will definitely want to separate variables. We'll start there. Next step. And now the variables are separated. Now that we have separation of variables, we can take the integral of both sides. And we get to this integral. And we talked about 3 different ways of approaching an integral, like this one on the right. Here are the 3 ways we can attack that integrand. One way is to add 2 and subtract 2. And then we essentially have this over itself minus 2 over 2 plus x. And so that over itself is 1 minus, and then 2 over 2 plus x, or 2 of those. And so we get quickly 2x minus 2 times the natural log of the absolute value of 2 plus x plus c. Here's another way we could have done it. 2 plus x divided into x, we could do long division. X divides into x 1 time. 1 times the divisor is the divisor. X minus that is x minus x, which is 0, and we have negative 2. So the ratio is equal to the quotient plus the remainder over the divisor, 1 and negative 2 plus x's, which is exactly what we had here. We take the antiderivative, we'll get x minus 2 times the natural log of 2 plus x plus c. The third way we could have done this problem is with the u substitution. If we let u equal the denominator, then u is 2 plus x, and also x is u minus 2, and du is equal to 1 dx. So the integral becomes u minus 2 over u du, which is again just u over u minus 2 over u, which is u minus 2 natural log of the absolute value of u plus c, and u is 2 plus x. And we can wrap that 2 into the constant, so we have just x minus 2 times the natural log of 2 plus x plus some constant, which is what we get in every scenario. So there's 3 ways we can do the right side and get to this stage. We're trying to solve for y, so next we will exponentiate both sides to undo the log base e. Now we have the absolute value of y is equal to the e to the x times e to the 2 natural log of x plus 2 times e to the c. And I'll put the e to the c in first, and then the e to the x, and then e to the x plus 2, and we'll write this as an exponent. And since we're squaring it, we won't need the absolute value symbols anymore. So this is just some constant. It might be positive, it might be negative, so we don't need that absolute value. And we will add these exponents, x plus 2 squared. Final answer, or if we prefer, we can expand that binomial and get x squared plus 5x plus 4. All right, this is exponential growth's differential equation. So we know that the solution is y equals some constant times e to the kt. Initially there's 200 bacteria. Initially means when t is 0. So if t is 0, this is 1c equals the population of 200. C is 200. Also, this is k. K is 0.5. We have the solution. So if that is our population, then we know from previous chapters that the average y value will be the integral of y from a to b times 1 over b minus a. This is a formula that we need to have memorized. It's the average value formula. So for part B, our answer is this expression, and this is a use your calculator type of problem. So we'll use our calculator, and we get our final answer of about 5,896.526 bacteria. All right, I hope that helps. If you had any questions on number 8, part B.